So in the last video, we talked about scale drawings and how they're proportional to each other. And like any proportional relationship, there's a constant of proportionality for that. In scale drawings, we call that the scale factor. Now, the scale factor is defined as what you multiply the dimensions of one picture to get the dimensions of the other. Now, it's always what you multiply by. So that's the only difference between what you would normally do with constant proportionality, okay? So in this example here, if you have to go from 2 to 4 or try to go from B to A, right? So they're trying to grow the image because B is smaller than A. So we try to go from B to A, right, which is this direction here, you would expect the scale factor to be bigger than 1 because if it's getting bigger, you have to multiply the picture, right? Now, in this case, it's pretty obvious that 2 is matched to 4. We talked about that in the last video, the sides that have matched to each other. And make sure you use match sides when trying to figure out the scale factor. You couldn't use this 2 and a 7 of the other picture because they're not exactly the same thing. You have to compare sides which are related to each other on the two different pictures. So to go from this 2 to go to the 4, it's pretty obvious that you have to multiply times 2. So it's a scale factor of 2. And notice it's bigger than 1 because you have to get bigger. Now, a lot of the questions in the assessment are actually going to be like that. They're going to have a picture growing, and they're going to say which of these values could be a reasonable value for the scale factor. In a lot of those, you don't have to calculate the actual value, you just have to guess. What they're looking for is that you understand that in order to get bigger, you just have to make sure the scale is bigger than 1. So any value, even if there's multiple values or multiple options, which is bigger than 1, would be okay if the picture is growing. But what if the picture is shrinking? Like in this picture here, if you're trying to go from A to B, right? So notice that the numbers are getting smaller. So even though you have to multiply for the scale factor, you would have to multiply by a fraction because you really have to divide. So you got to get smaller. So in that case, a reasonable scale will be a number that's smaller than 1. So when you're getting to a smaller dimension, like it is in this case of going from A to B, it makes sense that the scale factor is a fraction or a decimal that's smaller than 1. So again, you're going to see a lot of questions in the test like that, which will say which one of these is a reasonable scale factor for this situation. If the picture is getting smaller from the original, then that means you're looking for any value that is smaller than 1. But in some questions, they will ask you to expect what is the actual value. Now you will notice that in here, you have to, basically it's half. So you have to multiply times half. Now notice that half is the inverse of 2, right? Because 2 over 1 is the same thing as 2. And so 2 over 1 and 1 over 2 are inverse of each other. So that's right. Once you figured out one of the scale factors, the other one, going in the opposite relationship, is just the inverse, the same way it is with constant proportionality, right? They're just in the inverse of each other if you invert the relationship. But I want to give you guys a hint on what you can do to always find the correct constant proportionality. So the way you do that is by finding the scale factor through getting the destination divided by the origin. What do I mean by that? Say, for example, I'm going from B to A. So I'm going to the left here, okay? Well, the destination value is 4, and the origin value is 2. So if I do 4 divided by 2, I get my scale factor, which is 2, like we discussed before. Now, if I was going from A to B, then it would be the other way around because my destination would be 2 and my origin would be 4. So I'll put destination on top, 2 divided by, can you barely see that number? Let me get a darker color. So you get a 2 divided by 4, which will be half. And that's why they're inverse from each other, because the destination and the origin flipped. So that's basically it. This is how you find the scale factor. The scale factor is the number that you have to multiply one picture's number to get to the number in the other picture in the same related matched section of the image. If you're getting bigger, it's going to be a scale bigger than 1. If you're getting smaller, it's going to be a scale that's smaller than 1 or a fraction. To find a scale, Find a part of the picture for which you have match numbers. So, like in this example, I had the 4 and the 2 on the bottom part of the triangle, and then do the destination divided by origin. Just make sure that you call the destination the direction that you're going in the problem, right? And you will notice that if you try to find the opposite destination or the opposite direction, you have the inverse scale factor. And that's all there is to it. On the next video, I'm going to tell you how to use that scale factor to find out mystery numbers like the X and the Y in this diagram.